Hello Falcha, good to see you. Thank you for watching this video. My name is Dr. Elsa Panciroli and I am a writer and scientist, and I want to tell you about my new book that is coming out this month on the 22nd of April on International Earth Day, and it's The Earth, a Biography of Life. Now in this book I have told you the story of the formation of our planet right the way through from its very beginnings as basically particles of dust in this empty universe through to the incredible green verdant world that we have today with all of its many ecosystems and plants and animals. And of course that's such an enormous story. It's very difficult to break it down into manageable pieces. So this book attempts to do that, to basically bring it to you in a way that you're going to find hopefully interesting, fun, full of incredible facts, but also picking out some of the organisms that I personally think are some of the most fascinating, but also are perhaps the pioneers of particular behaviours or the creators of niches in ecosystems, or for some other reason are really, really important in this story of our planet. So when you buy this book, you'll find inside that there's a sort of, first of all, a really beautiful sort of summary of the contents of the book and what you're going to be reading about. And each chapter is broken down by geological time, so we go through time from the Precambrian all the way through to the modern day. And it's beautifully illustrated with a mixture of these sort of old lithographic style artworks with some more modern artworks, including those by up-and-coming paleo artists, to just basically to give you an idea of the different creatures that we're talking about. So there's a mixture of fantastic sort of vintage art with maybe more modern artwork like this one, which is by Grace Farnham. Now I thought today, as a sort of introduction to the book, that I would read a little bit from it so that you get a flavour of what the writing is like. Now this is written really for everyone. You don't have to be a trained scientist to understand this story, because it's our story, it's our fundamental story of life on the planet. So this book is for everybody. And I wanted to start off with near the very beginning of Earth's story in the Hadean, which lasted over 600 million years. So this is right at the beginning of the formation of our planet. The Earth began in the hellish Hadean, which lasted 600 million years. The Moon was formed from an impact with another protoplanet, bringing the water that would form our atmosphere and oceans. And although Earth seemed inhospitable, by the end of the Hadean, our oldest common ancestor had appeared, and the epic tale of life's evolution had begun. So that's our sort of summary paragraph. In the first days of the Earth, our planet was unrecognisable. It formed approximately 4.6 billion years ago from dust grains orbiting the newborn sun. These grains clumped together and collided, growing to form the first protoplanets, including our own. The process only took about 20 million years, a mere blink in geological time. The Earth was a hot mess, battered by a rain of impacts from other protoplanets and asteroids, which kept most of the surface molten. Heavy metals in this magma soup sank to form the core, which produced the Earth's magnetic field. The name Hadean comes from the Greek god of the underworld, Hades, and it was chosen for this time period because the extreme conditions were reminiscent of the Western classical concept of hell. For much of this time period, Earth was incompatible with life. The surface temperature was over 200 degrees Celsius. That's 390 degrees Fahrenheit. There was almost no oxygen, and the lack of ozone layer meant the planet was flooded with deadly radiation emanating from our furious young sun. Slowly the Earth cooled, and it formed a crust. By the end of the Hadean, this crust began to move, and plate tectonics was set in motion. A day, well, that's one full rotation of the Earth, was only 4 hours long at first, gradually lengthening to 10 hours by the end of this eon. The sun was only 70% as bright as it is today, and the moon was much closer and would have been enormous in the sky. Towards the end of the Hadean, a huge number of asteroids pummeled the Earth and other planets in our young solar system, and evidence for this is found in the pockmarked moon, which bore the brunt of the impacts. In the last 50 years, scientists have found Hadean rocks in Australia, Canada, and Greenland, but most have been recycled through plate tectonics. Although the earliest fossil evidence is not found until much later, researchers believe that the first life on Earth may have appeared by the end of the Hadean. They call it Luca, L-U-C-A. That's the last common universal ancestor. And from it, all life on our planet evolved. It probably began through chemical reactions that produced simple organic compounds, including the building blocks of life. Luca can be studied using the genomes of living species, including single-celled organisms. Scientists trace these patterns back through time using molecular clock analysis, and this counts the number of mutations in genes to work out when different branches of the tree of life split. From the myriad protocells that developed on our early planet, only one lineage survived. This simple life diversified, transforming the Earth and creating conditions that made it possible for more complex organisms to emerge. Now I'm going to skip forward in time a little bit to talk about the Devonian. And I think I'm actually going to go straight into one of the organisms. Now this is one that I'm sure you've all seen before. This is the beautiful ammonite. And I think I have also one here. Reconstruction of what it might have looked in life. Now everybody loves an ammonite. And many people I know have them probably propped up in their mantelpieces and in their collections. So ammonites, they're spirals of geological time. They're one of the most common and recognisable fossils. These marine molluscs lived in the sea, growing inside spiral shells, where their soft bodies were protected. They had multiple squid-like arms protruding from the open end, searching for food. Now, after thriving for over 340 million years, they became extinct around the same time as the non-bird dinosaurs. As well as being an important index fossil for geologists, ammonites have also played a major role in folklore for centuries. So that's your introductory paragraph. During their epic 340 million years existence, ammonites, or more correctly, ammonoids, to which ammonites belong, populated seas and oceans all over the world. They came in a mind-boggling range of sizes. The very smallest would fit easily on your fingernail, whereas the very largest were over 2 meters across. So that's 6 feet across. They are a type of mollusk that group also includes slugs, snails and squid. And their soft, squishy bodies, they're rarely preserved in the fossil records, so it's difficult to work out the details of their anatomy and their way of life. It's likely that most of them lived in open water, from shallow seas to the deepest oceans, but probably not in brackish or freshwater environments. Some species fed on plankton, and there is evidence that they may have squirted ink for defence, similar to their relatives that are alive today, the squid and the octopuses. Now, despite their incredible success, ammonites died out at the end of the Cretaceous, in the same mass extinction that killed the non-bird dinosaurs. Only their closest relative, the nautilus, is alive today. And their sudden disappearance remains a mystery, but it is likely that the mass extinction decimated plankton in the oceans. And this plankton included not only the ammonites' primary food source, but it also included their eggs and left them unable to recover. However, ammonite fossils are so commonly found and easily recognised that their legacy lives on, incorporated into human cultures around the world. Their spiral ghosts are an enduring symbol for paleontology itself, among scientists and the general public alike. Ammonite shells are made up of multiple chambers that increase in size from the centre of their spiral outwards. Most of these were empty. The animal itself was only occupying the largest chamber at the opening of the shell, and the rest of the chambers were likely filled with gases that could be adjusted to allow the animal to float through the water column. The ammonite's soft body had as many as 10 arms, digestive organs, probably an ink sac, and gills. Many of them had a hard palate in their mouths called a radula, and this allowed them to crush up plankton and larger prey. Although we associate ammonites with their trademark spiral shape, there were species with very different shell structures. These irregularly coiled ammonites are collectively called heteromorphs. Scaphites or Scaphites, for example, grew in the shape of a number 9, whereas Baculites was almost completely straight, resembling a kind of longbow. And the bizarre ammonite Nipponites looked like a pile of discarded string, seemingly growing in all directions. Now, ammonites existed for such a huge portion of the Earth's history, and there were thousands of species that are relatively easily identified by the shape of their shells and the sutures between their shell chambers. Species often originated and became extinct over very short time periods, some species persisting as little as 200,000 years. So this, coupled with their global distribution in the oceans and seas, makes them an ideal index fossil. So hundreds of ammonite zones have been established by geologists and can be used to correlate the ages of rocks. This approach to understanding rock stratigraphy, and that's the study and classification of rocks, was pioneered in the 1850s by German geologists Friedrich Krenstadt and Albert Opel, and it was based on their research in the Jura Mountains of France and Switzerland. Thanks to this work, pockets of rocks can be compared across huge distances, using the species preserved within them to work out the age and the context within the yawning depths of geological time. Ammonites are so widespread that their fossils have a rich cultural legacy, recognised and collected by people around the world for millennia. The name ammonite comes from the Egyptian god Ammon, who had ram's horns resembling the shape of this fossil mollusk. In China, ammonites are also likened to ram's horns, and in Chinese folklore they represent an unknown animal that had turned to stone. Ammonites have been part of human cultural beliefs and practices since at least the Mesolithic. There is an ammonite incorporated into one of the upright stones of a Neolithic long barrow near Bath in England. Ancient Sanskrit texts suggest that ammonites were the traces of some kind of worm, and in Hindu traditions they're considered precious for their resemblance to the chakra held in the hands of the god Vishnu. So as well as inspiring origin stories, these fossils have also been used in medicine and in ritual. The ancient Greeks believed ammonites cured blindness and infertility and protected people from snake bites, whereas the Romans placed them under their pillows to give prophetic dreams. In medieval Europe, ammonites were thought to be the remains of snakes that had turned to stone, often turned to stone by saints. These snake stones were used as charms to heal farm animals and cure ailments like bites and stings. Meanwhile, in North America, ammonites were called buffalo stones by the Blackfoot people and used in hunting ceremonies, and the Plains and Navajo nations called them Wanisunga, life within the seed within the shell. So that's a little taster of what you can find when you dip into individual sections of this book. It can be read from start to finish as one long epic tale, or in manageable chunks when you have a snatch of time to yourself to read a nice book. So out the 22nd of this month, The Earth, a Biography of Life. You can pre-order it now.